All right, this is the the last video here I'm going to make, and this is related to the pH scale. And again, it's called the pH scale. So, what value do we use to determine whether something's an acid or a base? Well, we're going to use that pH value. Okay. So here it runs from 0 to 14. 7 here is neutral, and I'm just going to go back a few slides here and talk about that what that neutrality means. Again, in a body of water, when I measure the two concentrations of the hydronium and the hydroxide, when they are equal to each other at 10 to the negative 7, 10 to the negative 7, that means that they are canceling each other out, so to speak, right? They're equal to one another. So that gives me neutrality. That gives me that value of 7. So both the hydronium ion and the hydroxide ion are at a value of 7. So they're equal to one another, and that's where that neutrality falls, or that neutral point on the scale. Above 7, from 8 to 14 is going to be a base. Below 7, 6 down to 0 is going to be an acid. And again, this is always based off of the value of the pH, is what we use to determine if it's an acid or a base. I've already talked to you about this equation, and we're going to learn today how to use it along with a few others. But this is basically talking to us about the power of the hydrogen, right? The number of hydrogen ions that are released by a given substance and acid into a solution, right? So the next slide talks to you about a few household items if you're curious, things in your house and where they fall on the scale. And then the last slide here talks to you about these two equations, which I already covered in the first two, equations that I've already covered in a previous video. And then we have this third equation down here, which I think is important just to note. If we take a log of 1 times 10 to the negative 7, we get 7. If we take a log of 1 times 10 to the negative 7 for the hydroxide, we also get 7. So this 7 for the pH came from the concentration of the hydrogen ion, or the hydronium ion, and this came from the concentration of the hydroxide ion when they're found in a neutral solution. Again, going back up here to this slide here. So if I take a log of these two numbers, I get 7. And so again, 7 plus 7 plus 7 is going to give me, and this thing is acting up on me, I'm sorry about that, is going to give me 14. So this is where this equation comes from. The pH plus the pOH is equal to 14. Two more formulas that I'm going to write down that I think you should know are, what if they don't give me the concentrations? What if they give me a value of pH or pOH and they want me to go back and determine the concentrations? Well, then we're going to use what's called an inverse log. So to determine the concentration of the hydronium ion from the pH, we're going to do 10 to the negative value of the pH, and for the hydroxide, it's going to be 10 to the negative value of the pOH. So these are the equations that we're going to use to answer a few questions. So taking a look, the first one, they've given me a value of 5 for the pH. So to determine the pOH, I'm just going to simply take 14, if it picks it up, 14 minus 5, and that's going to give me 9. So for the pOH, it's going to be 9. So now if I want to determine these concentrations here, again, I'm going to just go back. They've given me a value for the pH and the pOH, so I'm going to put a star by there. I'm going to use these two equations to determine the concentrations. So for that hydronium ion, it's going to be 10 to the negative value of the pH. Well, what was the pH? The pH was 5. So this is going to be 10 to the negative 5. So here I have 10 to the negative 5 followed by an M for the molarity for the concentration of the hydronium ion. For the hydroxide ion, again, it's 10 to the negative value of the POH. In this case, that value is 9. So this is going to be 10 to the negative 9th power. So 10 to the negative 9 followed by an M for the concentration of the hydroxide ion. So that was our first problem there. Number 2, they give me a value of 13 for the POH. So again, I'm just going to subtract 14 minus 13, and that's going to give me 1. So I have a value of 1 here for the pH. And then I can go back and I can determine the concentrations just like I did before. So that hydronium ion is going to be 10 to the negative value of the pH. In this case, it's 1, so it's 10 to the negative 1. So 10 to the negative 1 power, and that's a concentration of the acid. And then for the hydroxide, I get 10 to the negative value of the POH, and that's going to be 13, so this is going to be 10 to the negative 13. So here, 10 to the negative 13 for the concentration of the hydroxide ion. Down here, they give me a concentration of the hydroxide ion of 10 to the negative 3. So in this case, I'm going to use this equation, which I'll bring back up here. So to determine the value of that POH, I'm going to use negative log of the concentration. So here, POH is equal to the negative log of 10 to the negative 3. So if I take a log of 10 to the negative 3, that's a negative 3. And again, we're going to multiply that by that negative. Negative times a negative gives me a positive, so it's going to be a positive 3. So for the POH, it's going to be 3. And then I can use the POH to calculate for the pH. So that's going to be 14 minus 3, which is going to give me 11 for the pH. And then finally, I can use that pH value to determine the hydronium concentration. So that's going to be 10 to the negative value of the pH. In this case, it's going to be 10 to the negative 11. And that's molarity. Sorry, my pen's acting up a little bit. Let me see if I can erase this and write up proper M. All right. And then the last problem that we have here, they've given me the concentration of the hydronium ion, so I'm going to convert that into the pH. So again, the pH is equal to the negative log of 10 to the negative 9. So log of 10 to the negative 9 is a negative 9. I'm going to multiply that by that negative, and I'm going to get 9. So the pH here is 9. Then I'm going to take 14 minus 9. That's going to give me 5. So I'm going to get 5 for the POH, excuse me. Let me write a better 5 over here. That one looks pretty bad. And then finally, I'm going to use this the value of the POH to determine the value of the concentration of that hydroxide. So again, that hydroxide is equal to 10 to the negative POH, which in this case is a 5, so it's going to be 10 to the negative 5. And those should have two concentrations, those M's behind there. Okay, so those are 4 sample problems that I've worked out. The last thing that we're going to do is we're going to determine if these are an acid or if they're a base or if they're neutral. And remember, I told you that when we are going to determine if it's an acid or a base, we're going to be using that pH value. So we're going to be looking at the pH value. Always use the pH value to determine if it's an acid or base. So here, the first problem, this is going to be an acid. It's less than 7. So it's a weak acid, not a strong one. Number 2, value of 1 for the pH. That's definitely an acid, strong acid. Much like an acid that you would find, the acid you would find in your stomach has about a pH value of 1, roughly. The next one has a pH value of 11. That's greater than 7, so that's going to be a base. And then finally, the last one, the pH is 9, and that's also going to be a base. It's greater than 7. So hopefully that helps you out in calculating the values for these variables here, and um, and that's going to be it for this presentation. So if you have any questions, email me or send me a message through Google Classroom. All right, well, I thought I was done, but there's one other thing that I wanted to just, make clear or clarify for you here. So looking back at this pH scale, I have the numbers listed from 0 through 7. So I have 1, 2, 3, 4, 5, 6, 7, and I just wanted to talk to you about why this is a base 10 or why we use a base 10 here. So if I have the concentration of the hydronium ions like I have over here at 7, there's going to be a certain amount of that concentration in there. I'm not going to get specific to say what the amount is, but if I go from 6 and I go from 6, from 7, if I go from 7 to 6, that means that the concentration is going to increase by 10. And if I move from 6 to 5, it's increasing again by another factor of 10. So it'd be 100 at 5 compared to 7. And then again, increases by another factor of 10 to 4. So now you would have an increase of 1,000. And as you keep moving to the next consecutive number, you have that the concentration is increasing and increasing by factors of 10. That's why we use this as a base 10. And that's why the smaller the number is on the scale, the stronger the acid is, because we're increasing that concentration. We're increasing that concentration of the hydronium, that hydronium ion, right? And if we go back the opposite direction, let's say to 8, to 9, to 10, 11, 12, 13, and 14, well, then we're decreasing that concentration by a factor of 10. So there's going to be a factor of 10 less, so that those hydronium ion or the hydronium ion that's in the solution, if I go to 9, it again decreases by another factor of 10, another factor of 10, and so on and so forth. So that was the last point that I wanted to make clear, and hopefully that kind of sums it all up for you.